Our presenter for today is Mr. Thomas Hall. Tom is the Sales and Application Manager at IntelliSense. He has a wealth of experience in MEMS design, CAD, FEA simulation, customer education, and training. He holds a degree in mechanical engineering from Boston University. If you are a current or a prospective user of IntelliSense and would like to be informed about the latest software developments, you would like to contact Tom. Over to you, Tom.
Hi. Thank you very much for having me, and thank you everyone who's watching. The main topic of today's webinar will be the module Simple from IntelliSense, and it's for system-level analysis and multi-domain phenomenon simulations. So during this webinar, we'll cover basic schematic design using Simple. I'll show you how to export your schematic to our tool Blueprint to view the mask, and then we can also mesh it for use with thermoelectromechanical, our FEA module, or our other meshing tools. There are multiple benefits to using Simple. Mainly, it can save you a lot of time. It's quicker than most FEA analysis methods. You can perfect your design by making it'll be easier to debug your design with the easy-to-use schematic drag and drop window, and you can automatically export your mask and your mesh. All right. So when you open Simple, you'll see this basic schematic layout. It's basically just a little map with a grid, and you'll notice a few important things. On the right, you have all of these drawing tools, and on the left, probably the most important part is the element library, which includes digital elements, electrical elements, general elements. We'll be working with some of these today. MEMS elements. We'll be doing an example later with a cantilever beam. And lastly, thermal elements. And all of these elements show up when you drag and drop them as little symbols. I need let me open a new window here. So first we can start off making a very basic design. We'll make a basic cantilever beam. I just need to find the anchor terminal. So this is the anchor that our beam will hang off of. And we can choose a basic beam, and Simple is very easy to use. Everything just attaches with little lines that you draw straight across. And then the most important element that you'll see in many of the designs that you'll make is the multi-domain bus. You can access it by clicking right here, and you can insert this splitter. And you'll notice that all along the right side of it, it has these variables that you can change. So X, Y, and Z represent the displacement in the X, Y, and Z direction. Rx, Ry, Rz are the rotational displacement around the X, Y, and Z axis. These are your general forces in the X, Y, and Z direction. Your moments about the X, Y, and Z axis. Your voltage input, output. Your temperature and the thermal power. So for this basic example, we'll, for our output, we want to analyze the displacement in the X, Y, and Z direction and the rotational displacement around the X, Y, and Z axis. So for this, our output, this red pin here just is your output, and you attach it to the elements that you're looking to determine in the end. So it's very simple. You just draw these lines, attach everything. And then in this first example, we'll have a constant force in the X, Y, and Z direction and constant moments around the X, Y, and Z axes. So for a source, in general elements, or sources, we have constant. So we'll need two of those. They're facing the wrong direction, and we can flip them around right here. Then for the voltage, we'll need a ground, which we can draw it right out to here. And then for the thermal elements, we'll put a basic heat sink and connect it like so. And you'll see that with all of these elements, when you double-click them, you can define all of the parameters. For example, with the beam, you can pick from multiple materials from our material database. You can add your own materials into the database, and then they'll show up right here. The length, the width, the bloat, which is one of the parameters used for damping. And so we can start out with a basic DC analysis. So I have it open right here with everything defined. So for this example, it's a 100 micrometer long beam, and we have a constant force of 1 micronewton in the X, Y, and Z direction, and 0.1 nanonewton meters in around the X, Y, and Z axis. And again, we're just looking to receive an output for X, Y, and Z displacement and rotational displacement around the X, Y, and Z axes. So you'll notice these buttons here. It's for DC simulation, AC, transient, and the steady state waveform analysis. So for this one, just to start, you can start with the DC static analysis for the beam at steady state. And you can select all of your settings for what you're looking for with your output. The fact that we placed the pin there and drew the lines to X, Y, Z, and these three, that's automatically selected here. And here you can change your convergence criteria. So it uses the Newton-Raphson method, and you define your maximum number of Newton-Raphson iterations here. And then once you press OK, at the bottom here, this is the messages window. It's kind of like a log file, but you can view it live. And already we have our answers for X, Y, and Z displacement. That is in newtons. No, that is in meters. And Rx, Ry, and Rz, which are in radians. And so another thing you can do is an AC analysis. So I have the same example open here, but instead of a constant force, we have a constant force for X and Z, but in the Y direction, we have a 10 micronewton force at 1,000 hertz frequency. So for a basic AC simulation, we just go right here, or we can click the AC simulation button here as well. And we're looking for the amplitude of, or the displacement in the y direction with respect to frequency. And again, you can change all of the settings here. Most of the simulation modes, you can have control over your convergence criteria and simulation settings and all of your outputs. So when we press go, some of the simulations take a little time to run, but most of them are very quick. And so you'll see your plot manager show up here. So we can see the magnitude of y with respect to frequency. And in the 2D viewer, which is one of the tools included with Simple, it gives you a lot of control over your axes and the format of everything. If you're looking to export your data for use in Excel or MATLAB or some other tool, if you double-click on the data line itself and then click Data, it'll show you a simple list with all of your results, which you can then copy into Excel. Another useful tool here is WaveRunner, which is just another plotting tool. And with this, say we wanted the X displacement, the Y displacement, and the Z, you could plot them all on one chart. And it gives you a little more control. It's good for presentations to export your charts. Then we can also do a transient analysis of this same beam setup with respect to time. So you set your basic time step parameters. So we'll start at 0 seconds and at 1.5 milliseconds and go in steps of 75 microseconds. And for this one, we'll do 3D visualization. So we want to look at all nodes. Normally, it would just show up like this. So we'll select that. And okay. Okay, so here we can see that it's giving us every output we could possibly want. But in this case, we can take a look at a 3D visualization. And for here, if you're interested in the small details involved, like the dimples and holes, you could select them here. But in this case, it's a simple beam. So here you can drag it around, look at it any which way you want. And say we're interested in the displacement in the y direction. You can flip through like that, or just have a continuous animation. And you can change your deformation scaling. And one of the interesting things about this tool is you can save your animation, either an image from it, a series of images, or an ABI file. So again, it's good for presentations. All right. So then another great use of Simple is system macro model extraction. So say you have your design already made up in your FEA tool, like thermo-electromechanical. Here we have a micromirror, and we have it designed, we have it all ready to do our finite element analysis. But then you want to attach it to a more complex system, or make an array of mirrors, or just take a design you already have and incorporate it into a more complex scheme of devices. You can use the macro model extraction tools that are built in to thermo-electromechanical that will export to simple. So within TEM, within the simulation settings, we have the macro model extraction tool. For this one, we'd be doing electromechanical reduced order modeling because we have the electrodes on the mirror itself that are causing it to move. And then this actually takes a while, so I have it open in the background already. Right here. So it won't show up as the actual shape, it'll show up as IntelliSense TEM macro model. Let me get rid of the message window so there's more space. So in simple, once you export your macro model from TEM, you click on the macro model template, which is in, I believe, the MEMS elements folder of the element library. So you click on the one you want because you can have more than one, and then you can load your macro model file. TEM will export, I believe it's 4 important macro model files, and they'll all be placed in the same directory. And then for simple, you click on the one with the .mac model extension, and then it will look for the dump files from the results from TEM. So with this, we can do a transient analysis of that mirror. So say, for example, we want to see X, Y, and Z displacement of a certain node. That's again, in TEM, during the process of the macro model extraction, you define which nodes you're looking at sort of as the nodes of interest for displacement. Let's open the message window back up. And all of the things that show up in the message window actually are also saved to a file here. So if you ever have any trouble with anything, you can send the file to our support team and they can help you out. So here we have our displacements versus time. So I mean, this is a good example where we could use Wave Runner. Be kind of a messy graph, but yeah. And again, here you can change all of your axis options and the colors. So with this, we can look at the, I need to run the simulation again, yes. For this, if we want to look at the different modes, we can create a visual representation of what is happening with the micromirror. And that is with our tool Visualise, which is also included with Simple. So once you output those 5, you can view the ROM visualization, which I have open over here. So it's just a basic animation of the mirror. This one maybe we would want more deformation. Yeah. Another thing you can do with Simple that could help you with your design for these beam examples, you can output to a mask, and it uses the information that you've defined in the beam parameters for the length and the width and everything, and it will export to Blueprint, which is our layout tool, which you can then use to export to GDS2 or DXF or a variety of different formats. With that, you're also able to visualize a simple 3D model, which we've actually already done. Or you can export your model to thermoelectromechanical for FEA analysis, which can be very useful. So here you would define your mesh size. Click mesh. Opened right here. And so the element library within Simple is very expansive. There's a lot of different things you can do with it. I certainly don't know what all of them do, and for that reason, we have our element documentation, which so say you have an element, you don't know what it does, you can go in here. So the beam we used before shows a picture of it, describes everything, and then shows and describes all of the parameters and all of the units. And then if you're ever looking for an element and you can't seem to find it, you can use the search function for what you're trying to do, and chances are it will show up. If you have very specific criteria of what you need it to do and you don't think that one of these elements will work for your particular application, you can always email support@intellisense.com, and we can help either develop a new element or point you in the direction of the one that would be most useful. So that is most of Simple. It comes with a lot of examples. Some of these examples are actually from this example guide. And so you can use it for simple circuits, springs, beams, all kinds of things. And then for things where you have your full design laid out already in your multiphysics tool, you can use the micromodel extraction and then import it into Simple and incorporate your design into more complex systems. And I think that is basically it. I will turn it back to you and open the floor for questions.
Thank you, Tom. There is one question. Can you see the equations derived from from FEM or from FEA analysis or not?
Can you see the equations from FEA analysis?
The reduced order equation derived from FEA analysis.
Reduced order equation from FEA analysis. Can you repeat the question one more time? I'm sorry.
As you mentioned, we can do a finite element analysis, and after that, we can try to get the reduced order model from that FEA analysis. Just speaking, it's going to be different K, M, and C matrices derived from finite element analysis. Can we see those values, or can we see the equations that you use to create those graphs from simple or not?
Well, within simple, I don't believe it's using the same solver as TEM, so it's a completely different method of solving, which is why it's quicker. But in here, we have the advanced guide, where you can see a lot of the equations from what's going on kind of behind the scenes in simple. And then, yes, so simple is useful for either in the beginning of your design process before you're ready for FEA simulation, when you just want to get the basics down, or towards the end when you're done with all your FEA simulations and you want to see how it works with different systems. I hope I'm answering your question correctly.
Okay. Is there any question? One question. Which damping models are represented in simple?
Which damping models are represented?
Yeah.
One moment. So for the different elements, there's different types of damping that are represented. So for the beam, with the gaps, you have different types of damping than for the other elements. It would be literal damping, and some of them have squeezed film damping.
Okay. There's another question. Can you compare IntelliSuite with other products? I'm not going to mention the name of those products, but there are several products that can do the same.
I haven't personally used any of the other products, but I think what's beneficial about Simple is that it works so closely with all of the other IntelliSuite modules, especially thermoelectromechanical and all of our layout tools. We have IntelliMask and Blueprint, and with those, then you can use your masks for our process simulation tools, which are very powerful.
Okay. There is no other question. Thank you for your time. And if you have any, okay, there is one question. Okay. Please send your question through email. We are going to send those emails, those questions to Tom, and we'll get your answers. Thank you very much. This is the end of the webinar today.
All right. Thank you very much for having me.